pistons, lock, heads, rocker covers, pretty much ready to go for the dress part. So we got Colton Bush, who's going to kind of bring us through the last part. So next in the process, Colton's going to put on the oil tank. So he's orienting that engine to be able to put it in position. So this is a big dry sump tank that's mounted to the side of the engine. So while he's doing that, I'm going to talk a little bit about leak tests and cold tests. So that's kind of the next part of the process. You want to talk about leak tests?
Yeah, so once you get the oil tank on, you're going to Daughenbaugh leak test, which is just checking for if there's any leaks. So your tanks are blockouts, you're going out here today, but it covers the intake and exhaust ports, and then also you're going to front cover all the water ports. Everything's sealed up and pressurized it. The water cavity is pressurized to 10 psi, oil cavities go to 3 psi, and it builds, and it will hold there at that pressure. It's monitoring that the whole time, and it'll be on test. And that's checking to make sure there's no air escaping from anywhere. So the timers on that is got to run for a certain amount of time without losing a certain amount of pressure that we have programmed into the machine. So with that, it lets us catch any of these, like say there's a rolled seal somewhere that we only can't cover. If there's a damage to the seal that goes around there, with that thing small as if there's an air laying across the seal, it's capable of catching that. So very helpful. It's one of our main quality gates. Our quality gates, there are several different checks we do throughout. You have torque return, you have response, SIDI, one-month leak test. So as the engine goes through that process, if it fails the quality gate, it can't go any further. We have to repair whatever is causing it to fail, and then pass that gate before it can go on to the next one. So that's how we ensure that if there is something wrong, we have the engine fully built, and then finding a cable thing down. So that helps us minimize when if there is a part issue, it's not tearing down the entire engine. It may just be one or maybe 2 parts. So that helps really minimize that area.
So next in the process, so once it passes the leak test, there's like Logan talked about, there's block-offs that are onto the intake exhaust, and each one of them has an individual port. So next we'll go on to the next station. Once we pass the leak test, we feel good about filling up the oil. So we've got where the oil pressure sensor is in the engine, we got a quick connect that we go to. We high pressure fill that with 115 oil, which is the factory fill of the LT6 and LT7 engine. And what's good about pressurizing through that is it actually primes the entire oil system. So we use high pressure oil to pump it through the engine to put oil everywhere we need to be. So we'll do that, and then that dry sump tank will top off the rest of the oil into that dry sump tank. Well, next, before Colton goes on and start, I'll talk a little about cold tests. Not that it's cold in there, but cold test is another big piece of test equipment. So this engine build card is actually the test pallet as well. So we'll roll this into a big piece of equipment. This big orange pallet that you kind of see those circular guides that I talk about, this machine will grab it, and then Colton, you point to the pin on the side of the engine there on the build card, right back here, right there, please. So that pin will actually get pulled out, and then it'll actually lift that orange pallet, we call it toaster saw. So you can imagine that one thing lifted up a little bit, and it basically allows the build cart to not be influenced, the test not be influenced from the cart. So any rattles or tools or anything on it won't impact the test. So we'll go in there, and what's cool about this line is every operator is actually a cold test operator as well. So we'll go in there, we put probes on all the spark plugs, we put pressure transducers on every intake port, every exhaust port. We hook up a highly sensitive oil pressure transducer. We connect to the oil, or the crank sensor, oil control valve, all the cam sensors, cam actuators. It's a big medusa of wiring and everything. And we close the doors and start the test. So one of the first things we do is I can actually tell you the gap of the spark plug. So we fire the spark plugs based on the current feedback. We validate that the gaps are correct. If there's any cracks in the ceramic of the spark plug, we can detect that. We charge an electronic ring around the ceramic of the plug. If we can mark to the inside of it, we know that we cracked the plug. So first thing, we'll check to make sure that the spark plugs are good. We then do a breakaway test and make sure the engine somehow didn't get locked up. Make sure it's freely spinning, and then we'll check cam and crank timing. So make sure that KJ, when you put all those timing moves on, make sure that they all line up right. So validate timing's good, and then we've got good signal. We'll then allow oil pressure to build up. So once we have oil pressure, we'll take it up, the highest we'll take it to 2,000 RPM. So it's done this with a big electric motor in the back. So big electric motor spinning the engine. 2,000 RPM is the highest we take it. We'll do an NVH test, if you remember noise operation harshness. So we're looking for any weird noises. We then actuate the variable valve timing. So we'll take the cams from fully advanced to low retard timing and valve them. We get test points on how fast they react, how far they react, where they return to, everything about the timing system we validate. Yes, sir.
How many degrees does the cam?
I knew you'd ask that. It's about 20 degrees each cam roughly. It's quite a bit of total phasing. Yep.
And that's based on what RPM?
It's all based on engine command. So based on the dynamics that they want, really not just by kind of torque or horsepower or what you're looking for from ECU command. And I'm not a calibration expert, but it will fully command all the time mechanics on how to move. So we'll validate that. That oil pressure, so we talked about oil control valve. This engine can control its own oil pressure. On the Gen 5 engines, it's higher or low setting. It's kind of linear. They're just kind of bi-modal. This it can actually utilize the displacement of oil pump to command oil pressure once. So they from high pressure down to low pressure and all the way back up. We'll do low speed NVH test. We can pull an intake trace. So we'll those pressure transducers on every cylinder. All the valve latch, I can make sure the valve latch is correct. All the intake and exhaust. And then we do a torque test. So in the torque test, we can look at compression, any type of bearing debris. We can basically validate if you can get into without ever running it. So it's a pretty neat test. It takes about a minute and a half to complete. So we'll come back out. So after cold test, we'll remove all that, and we'll pick up with Colton again, doing the starter. So we're on the dress line now. So long block's complete. We call it the engine dress line. So we're going to put on a lot of the dress components. So the starter on this engine is actually in the valley. So he's going to put the starter on the back here. So one of the things we don't have on the engine, because it's a decent amount of work and they always come apart as a pressure part, is we don't have the wiring harness on the engine. So in the normal build process of the design, you would have a wiring harness that's plugged in with all the cam actuators, cam sensors, knob sensors. It's called the 55 way. There's 55 pins on it. It's a big harness connector that the main harness of the car would connect into. That would be kind of on the back side of the starter if we had that harness on the engine. He's going to put on the alternator. The alternator is mounted on the front side of the engine. Next, you're going to put on the 8 ignition coil. So the engine doesn't have spark plug wires and doesn't have a separate coil. And all integrated into that unit. So ignition coil is that black plastic piece up top, and and then the rubber boot, is what connects down to the sparkle wire. So it'll drop those down through those tubes. So, KJ, let me know, it's very important. Let me know, and this is what's on the end of it. So typically right now, we have intake port covers, on the engine, so that as he's doing this, we don't inadvertently drop a bolt, into the intake manifold. So we don't have those with us to drill Colton right now, but there are some other things, again, in the process that's very important, to the builders, make sure they're doing, to make sure no foreign objects can get into that engine as it's going. We also have a clear expectation of all builders, so we talked about earlier ship to ships, when they park the engine to a cart, it's expected to have port covers on it, full engine cover, so when it's sitting by itself, we keep it sealed up. So we're gonna run all those down. If we have the harness on the engine, you can connect in the harness into all those ignition coils. Belt tensioners that go on the front. Yeah.
Yeah, so at this point, we don't have any wire harnesses on here, so there's a hard to tell, but we have a continuity test that we'll plug into, so then that will check, and just make sure that after whole test, all the electrical components are added, make sure that you don't have damaged wire anywhere, or a pin's not fully seated, or the wire got snapped at some point. So that checks your coil packs, your starter alternator, next to everything on the engine. Since cold test, the cold test can do the same thing as with the wire harness and cold test. It's able to check some of that stuff as well, and then everything we add right after the cold test that we can't have in there during the cold test to do the checks that we want. So it's just another test we do to ensure the wiring is good. Everything added.
Okay. All right. Next, Colton's going to put on the intake manifold. Intake, Colton. So the intake manifold is pretty cool. So we offer it in a black and then a painted red. So again, this is where it's fully LPC, part of the twin. So twin throttle bodies on the front of that. It's plastic. And what's cool is on the top there is where you'll see, I'll pull and point to it, but that's where the engine builder nameplate goes. So if you've got a LT6 or LT7, probably displayed right up when you open the hood, or I guess not hood, but rear hatch of the car, you'll see the engine builder signature, that hand built your engine. So it's one of the coolest parts in the process is we talked about job instruction training earlier. Really, it's the cool moment for an engine builder when they come out of training and get their engine builder nameplates and actually just start putting their signature and their name on the engines that they build. What's that?
There's a ceremony for that?
Not necessarily. Not necessarily. So one of the cool things we can talk about, is we have this program called Perfect Engine. So obviously every engine is perfect, but we created this little intro competition. As they're running torques down, you want it the first time run down to be green hit, and not have, mistakenly wrong bolt or debris on the thread or something you don't see right that causes bind up. So a perfect engine is an engine that goes together with zero bad hits. So it's very fun competition, where how many in a row perfect engines can get. So it's a fun engagement. Dennis is up there really high and perfect engines every month. But we have this engine, one of the ceremonial things, we have a wall inside the shop, if you saw on the tour, it's called the Perfect Engine Club. But there's basically different levels that you put their engine over nameplate on and they achieve a certain streak of perfect engines. And then there's a king of the hill who did 29 perfect engines in a row. So it's pretty cool. That's almost 3 weeks straight of building engines without a single issue. So So that's, what's that? Jeff Smith is current team leader.
We'll look for that.
Yeah. All right, so next, Colton's gonna put on the intake, or the, sorry, exhaust manifolds. Inside the shop, we removed, sorry, question, yeah.
I'm sorry, but going on that, how many torques, roughly, to get a perfect engine?
One of these, it is, 381, right? Right? 358. What's that? 580, yeah, 580. Gen 5 is 300 and some. So, he's, Dale asked me, put me on the spot there. So, on this engine to be complete, so when we're done with it, there's 580 total torques on the engine. Has to be perfect to get a perfect LT6 engine. So, in the process, we've got the heat shield will be on this engine. So, if you look into your car, there's a big kind of golf ball looking heat shield on these. So, we removed them because they're a pretty cool long tube style header that's actually underneath there. So for this demonstration, it's neat to be able to see them without the heat shields on it. It's a tri-Y long tube header. That's, you would think maybe for depending on what car you're working on, that Colton just installed it upside down if you're used to looking at it, but it's actually the way it's supposed to go. So as he's buttoning up exhaust, I'll talk a little bit about kind of the end of the process that we got a few minutes on, make sure there's any final questions. So the final stage after you do exhaust, put the engine over and down, we'll remove the engine from the part. Not to do this, we don't have a way to pull out, but there's a large dampener, we don't call it flywheel, that is bolted to the back of the engine. And that's what the transmission slot shaft engages into. So once the engine's done, we send it to another process called care, which is a full inspection on the engine, weighs it to make sure it's separating the amount of oil in it, and then make sure that there wasn't anything missed in any of the build process. So every engine from our facility, LT6 and LT7 after it's built, goes across town to a facility called Element. It's a Daughenbaugh facility. So every LT6 and LT7 engine, there's a whole 20-minute loaded hot test, which is also a bit of a break-in. So we're measuring dyno output. It's a fully loaded, wide open throttle pole to validate the engine. After that test, so when they put the engine in, they actually dye the oil. So at the end of the test, they shut the lights off and take a black light in there. And we black light inspect the entire engine. If we find anything that fails, we know we got an oil leak. So some of that repair process we talked about, if we find an engine and a dyno that has an oil leak, we obviously don't want to send it to you with an oil drip onto your car. So we'll bring that engine back and we'll repair it of anything if it can be repaired. Happens very rare, but it does happen. That's why we test, right? If everything is perfect in manufacturing, we wouldn't even test anything, and we would just put it together and ship it to you. So it's a very good step to protect everything we can on the quality of this thing. Yes.
So this engine just has the one oil tank?
Yep, just one oil tank. Yep. We fill it with about 10.5 liters of oil is what we fill it with. So that pretty much completes Colton's part. Let's give it a round of applause. Usually that's about an hour and a half. Like I said, in the real process, it would take a lot longer. There'd be a lot more involved in it, but it gives you a good feel of what these highly skilled technicians do every day. And it really, I'm proud. I love working there. I love managing that shop. It's a really fun place to work. So we'll wrap it up with if there's any open questions. I'll be around here for a few minutes if we're moving around. If there's anything you don't want to ask publicly, but yes, go ahead.
Is the projected engine life of a 6 or a 7 different from a LT6?
I don't know that answer. Yeah. What I have no idea to answer that. Yes. Yep.
How long did you purchase the engine build experience?
So there's not an engine build experience currently offered, no. We did that in the C7 program, but there's currently not, an engine build experience for this product yet. And we got, Ray.
I'm just a mic runner. I was just gonna make noise so we can hear the questions. I grabbed it from the back.
Oh, perfect.
That's it.
Right behind you.
So now everyone's getting quiet. I show up with the microphone. Like, what's the deal there? I'll tell you the questions.
This guy.
Right here. Turn it around the right way. Not
We
very
have
quick.
to put the drive belt on before we attach the oil tank.
What was that?
The drive belt, does it go on before the oil tank?
No, we don't put the guy down on there.
It just looks like there isn't much space to get around that.
So whenever they hot test it, they'll put the belt on, but before they test, we do not put it on. So there's room to get it on there, yeah.
Okay.
All right.
So do you give all these engine builders a trivia test?
So I don't know if we're gonna talk about it or not. Unfortunately, this is the beginning, sorry, but they have a lot of training. You want to talk to the training that a builder will go through before they can build an engine?
Yeah, we covered quite a lot of it, the JFT process, about 6 to 8 weeks for building, talk about the interview that they gotta go through, highlight a little bit of the, once they get their nameplate, kind of the significance of what that means when they start putting their names on it.
So I guess the answer is not really a trivia test, but go ahead and test. Before we let them just building engines.
Great question. Anyone else? I'll have, our builders stand up, give one final round of applause, and we'll.
And a round of applause, I think, for Brad.
All right, thank you.